Okay, let's unpack this core question that scientists have been wrestling with for, well, for decades now. Does the complex, high stimulus, often chaotic environment of a city actually make the animals living there smarter or, at least more agile in their behavior compared to their rural counterparts? We're really diving into this idea of adaptation, specifically what researchers call behavioral flexibility.
Right, and behavioral flexibility is it's the ability to pivot your actions when the rules of the game change. So think about a bird in the city. One day a certain trash can is easy food. The next day it has a new complex lid. That ability to, drop the old habit and invent a new solution is key to survival in these novel human-dominated spaces. And while a lot of lab studies have suggested that urban animals should be the most flexible because they encounter novelty constantly, well, the laboratory setting just strips away all the messiness of the real world, the predators, the competition, the other food sources.
Which is exactly why we love sources that take the experiment outside. Our deep dive today is centered on a fascinating 2019 master's thesis from DePaul University that went right into the Chicagoland area. It took this question out of the controlled cage into four distinct real-world habitats.
Yeah, that's our mission here. We wanted to see if urbanization and the specific type of land you sow, forest versus backyard, influenced songbirds' willingness to even approach a new opportunity. First testing their neophobia and then measuring their actual capacity to solve a demanding, multi-phase puzzle to get their meal.
So they weren't just using the standard urban versus rural binary, which, as you pointed out, can be way too simplistic. They created a proper matrix.
Exactly. A comprehensive 2x2 study design over 61 days. Yeah. Urban forests, urban backyards, rural forests, and rural backyards. They set up 20 unique feeder sites across the Chicago area and the surrounding counties. And the experimental setup itself was crucial. It was a raised platform feeder, but it was contained within a small wire mesh enclosure, small enough that only birds could really access it. But, and this is the key to succeed, a bird couldn't just reach through the wire. They had to physically enter the caged area. That cage itself was a major part of the test.
Okay, let's detail the curriculum here because this was like a graduate level course for these birds. It wasn't just a single barrier. It was a structured test of escalating cognitive difficulty that ran for over 2 months.
It really was. It was designed to separate the simply motivated birds from the truly flexible ones. The whole process had 4 distinct phases.
Phase 1 that lasted 14 days and was all about habituation.
This established the baseline. Bowls were open, there were no lids, and the shelled sunflower seeds were just freely available. This was testing pure neophobia. Were the birds willing to approach this strange new cage structure just for some free food? This was the period where the researchers hoped, everyone would get comfortable.
And then came the shift in phase 2, which ran for 3 weeks, the initial problem solving.
This is where the effort requirement really kicked in. Simple gray lids were added. The birds now had to learn the basic rule. If you lift this lid, you get the reward. And that transition from freely available food to food that requires physical effort and a learned manipulation, that's where you measure that initial problem-solving capacity.
Okay, next up, phase 3, the color association task. That lasted 2 weeks. And this is where it starts getting specific, right? Testing their ability to link a visual cue to a successful outcome.
Precisely. They introduced a conditional rule. Half the bowls had black lids, half had white lids, and only the white-lidded bowls were baited. So this forced the birds to move beyond the simple motor skill of lift any lid to the more complex cognitive skill of associative learning. Associating the color white with the reward and learning to ignore the color black.
And then the grand finale, phase 4, for 12 days, the reversal task. This is what separates the flexible learner from just a creature of habit, isn't it?
It is the definitive test of flexibility. They flipped the script completely. Now, only the black-lidded bowls were baited. So if a bird had successfully learned the phase 3 rule white equals food, they now had to actively suppress that ingrained successful learning and rapidly switch to the new rule, which is now black equals food. That quick adjustment where the successful strategy suddenly becomes the wrong one, that requires high cognitive agility.
So going into this highly complex multi-stage test, what was the governing theory? Did the researchers expect the city slippers to dominate?
Oh, absolutely. The leading hypothesis, and this is backed by many controlled lab experiments, was that urban birds, particularly those in the highly variable, stimulus-rich urban backyards, would be the least fearful of the new feeder, and that they would show the fastest, best problem-solving across all phases. It was a really firm expectation that urban life bred superior cognitive flexibility.
Okay, let's get to the results, because this is where the study delivers a spectacular twist. It just completely undermines that central hypothesis. We're talking about 2,574 total bird visits logged over 2 months, but the distribution is, it's astonishingly skewed. Tell us what those initial visitation numbers look like.
Well, they look like a desert in the city. When you look at all those observations, the rural sites accounted for a stunning 95% of all bird activity. Rural forests led with 62%, and rural backyards contributed to 33%.
Wait, so you're telling us that the urban environments, the very places we expected the least neophobia, they barely even registered. Urban backyards at only 5%, and urban forests were, what, statistically invisible at 0.16%? That is a massive contradiction to the initial prediction.
It immediately challenges that whole idea that urban life makes animals just generally less fearful of new human-made objects.
Yeah.
But the story gets even sharper when we look at what happened after phase one.
The moment the difficulty increased.
Exactly. Once problem solving was required, once the lids went on and the cost of food went up in phase two, visitation stopped almost entirely in 3 of the 4 habitats: rural backyard, urban forest, and urban backyard. They were happy to take free food for 2 weeks, but the moment effort was required, poof, they disappeared.
So the data isn't necessarily saying urban birds can't lift the lid. It's saying they chose not to. Is it safe to assume this wasn't a cognitive failure, but more of a motivational choice, a cost-benefit calculation?
That is the pivotal takeaway, yes. The researchers leaned very heavily toward this interpretation. The cost, which included the physical effort of solving the puzzle and the perceived risk of entering that cage, it just became too high relative to other food options they had.
And let's not forget that cage itself. It was more than just a physical box.
Oh, it was a massive psychological hurdle. During phase one, when food was free, nearly half the visiting birds, 47%, they got the seeds by just reaching through the wire mesh. They never physically entered the enclosure. But to succeed in phase two, full entry was mandatory. The authors strongly suggest the cage acted as an additional cognitive barrier, or a risk assessment, that many birds, especially the urban ones, were just unwilling to overcome when the food wasn't free anymore.
It's like asking a bird to go through a turnstile to get a small reward when they're used to just reaching over the counter. A minor inconvenience for us, but a major decision for a prey animal assessing risk. Were all species equally put off by the cage?
No, not at all. We saw clear species differences in risk tolerance and motivation. When you look specifically at the willingness to enter the caged area, black-capped chickadees were significantly more willing to go inside than either house finches or house sparrows. And this distinction is critical because it really narrows down who was even playing the game to begin with. And given that dramatic drop-off, our deep dive now has to narrow its focus. We have to look exclusively at the one resilient group that persisted through all 4 phases, the black-capped chickadees in the rural forest sites.
They really were the outliers, the persistent pioneers of this experiment. So they were the only birds to visit the feeder and actually attempt lid lifting across the entire 61 days.
So how did their performance evolve over that time?
Well, their efficiency showed clear improvement, which demonstrates genuine learning. We analyzed this using solving latency, which is just the time it took them from the moment they entered the cage to the moment they successfully got the food.
And what did that latency measure tell us about their learning curve? They got significantly faster the more they practiced. During phase two, that initial problem-solving phase, the average time to solve the task decreased sharply as they learned the basic mechanics. But the improvement really accelerated during the associative learning phases.
Give us the numbers on that. How much faster?
Okay, so the average solve time in phase two, the initial learning part, was 7.02 seconds. Once they mastered that and moved on to the color-based tasks, phases 3 and 4, they were consistently faster, averaging 3.97 seconds in the color association phase and 4.70 seconds in the reversal task. That's a measurable, demonstrable application of a learned skill.
So they learned the initial trick quickly, but did they get smarter about how they approached a puzzle? Did they make fewer mistakes overall?
So their efficiency, it increased most dramatically during that initial phase 2 learning curve. But what's interesting is their persistence, which we define here as the number of failed attempts before they just gave up and left. That didn't change much. They remained persistent throughout. They weren't necessarily learning to fail as frequently over the long term, but they were definitely learning to succeed faster when they committed.
That persistence, that willingness to just keep trying the difficult thing, seems directly linked to their rural forest habitat. Since this was the only persistent group, what does that mean for the original goal of testing behavioral flexibility across all 4 habitats?
It means we really couldn't achieve it. Since only the rural forest chickadees participated fully in phases 3 and 4, the study was fundamentally unable to compare associative learning and reversal flexibility between rural and urban birds. In fact, across the entire study, only 8 birds in total were ever seen attempting to open a lid of the wrong color during those tests. The sample size for comparing flexibility was just, too limited outside of this one motivated demographic.
Which brings us back to the great urban paradox. If we assume, as so many scientists do, that urban life selects for smarter, more flexible animals, why did the urban birds effectively boycott the experiment? Why the zero participation policy?
It almost certainly comes down to resource economics. The leading theory is motivation and, well, cost-benefit analysis. Urban environments are just incredibly resource abundant. Think of all the spilled food, the unsecured trash, the high density of homeowner bird feeders. For an urban bird, the energy cost of solving a caged, multi-phase puzzle is simply too high when they can just fly 50 feet and find an easier, safer meal.
They're working smarter, not harder, in a way. They have the cognitive capacity. They're just optimizing their energy output.
Exactly. The researchers specifically note that the novelty and difficulty of this caged food source may not have been a necessity for urban birds. They didn't need to innovate to find a meal. They just needed to locate the nearest overflowing trash can. You contrast that with the rural forest, where available resources might be more scattered, less reliable, more seasonal. If you find a new, stable food source there, even one that requires effort, you have a much higher incentive to stick with it.
And beyond alternative food, competition also played a huge role, right? Especially for mammals, which are particularly dense in backyards.
Oh, that's a huge confounding factor. The data showed that the species richness of all animals was highest in those backyard sites. And high mammal activity directly translates to high risk for a small songbird. If a site is constantly visited by a threat, the risk-reward calculation for the bird changes dramatically.
Can we point to specific culprits based on the habitat?
We can. Gray squirrels were present almost exclusively in the urban backyard sites, and raccoons were almost exclusive to the urban forests. And the thesis even referenced other research showing that the sustained presence of gray squirrels can reduce bird use of feeders by as much as a 99%. If they know a giant, aggressive competitor is going to raid that feeder, why should the birds spend time and energy mastering a complex skill there?
They're making an environmental security decision. It's just an incredibly clear example of how lab findings can miss the complexity of ecological competition and risk assessment. So if we step back and look at the big picture for you, the listener, this field study offers a powerful distinction. It's that cognitive capacity, the potential ability to solve a complex problem, which is what lab scientists usually measure, is fundamentally different from cognitive necessity. The external motivation and willingness to apply that ability in the face of real-world variables like competition, risk, and easier alternatives.
Yeah, it clearly shows that the black-capped chickadees in the rural forests who are facing potential food scarcity were the demographic with the highest necessity. They had to persist and innovate, and they showed measurable improvement in their performance because of it.
We often equate innovation and behavioral flexibility with success, especially when we talk about surviving in a challenging, dynamic urban environment. But if an urban bird is cognitively capable of solving the puzzle, yet actively chooses not to engage because an easier, safer food source is readily available nearby.
Well, this raises a really important question about how we even define success. Does true behavioral flexibility in an urban environment actually mean knowing when not to innovate? Is the most flexible, the most energy-efficient behavior simply sticking to the path of least resistance, even if it means foregoing the chance to learn a new, complicated skill? That's something fascinating to consider the next time you see a bird ignoring a difficult task.